So we talked a little bit about the augmented matrix and how to solve systems using that augmented matrix. And today we're going to just describe a little bit about matrix algebra, just how to add, subtract, and multiply these things. We know that in general a matrix is just a rectangular array of numbers. It's defined by the rows and the columns of that matrix. If we want to take and give the dimensions of all of our matrices come in a row by column form. This can be seen here. So if I state that the dimensions of these matrices, we have 1, 2, 3, 4 rows by 2 columns. In this case, we have 2 rows by 3 columns. And in this case, we have 4 rows by 3 columns. Two matrices are going to be equal if they have the same dimensions. So these rows by columns need to be the same, and the corresponding elements are the same. So these terms inside are called our elements. Those elements would have to be the same. Now let's go back up to our initial slide. We want to name those elements. If we want to name the element in the first row, first column, that's A sub 1, 1. First row, second column, A sub 1, 2. If I wanted the second row, second column, that's A sub 2, 2, etc., etc. So now let's talk a little bit about adding and subtracting two matrices. First of all, you have to have the same dimensions, and once you have those same dimensions, then all you're really going to do is add or subtract the corresponding elements. So in this case, we have the same dimensions, both are 3 by 2s, and then our first row, first column numbers, we add those, get a total of 3. First row, second column, 4, etc., etc., etc. And that's the sum of the two matrices. Now, matrix addition is commutative and it's also associative. So you can add in either direction and group in either direction and go ahead and add. If we want to subtract, we're just making sure once again the dimensions are the same. They're both 3 by 2s, and then subtract off corresponding elements. So we have 5 minus 2 is 3, negative 2 minus negative 2 is 0, negative 1 minus 0 is negative 1, 3 minus 1 is 2, 1 minus 4 is negative 3, 0 minus negative 1 is 1. And that's our final matrix. If we talk about doing a scalar multiplication, it's like multiplying all elements in the matrix by a single number. So you'll see over here, this is a general case, x is my scalar, and I'm multiplying all elements inside by x, which leaves me with this matrix. So if I'm asked to do a scalar multiple on this matrix over here, I multiply 4 by every element inside the matrix. It's kind of like a huge distribution. So I have 0, 4, 4, negative 8, 8, 12, 16, 44, negative 20, and 12. If I want to do a little more complex multiplying and adding and subtracting, I take a look at this example. I've got two scalars I'll need to multiply, so that gets me a total of 15, negative 18, 9, 0, negative 12, 24, 30, negative 33, 36. It's one scalar multiple. And from that I'm going to say add, because I'll multiply in my negative 2 and get negative 4, 8, 0, negative 10, negative 22, 4, negative 10, 0, and 20. And then I'll take and add these two up. Corresponding elements get me 11, negative 10, 9, negative 10, negative 34, 28, 20, negative 33, and 56. Pretty straightforward as far as matrix addition and subtraction goes. Now in this case, you'll notice if I do my scalar multiplication, here I have a 2 by 2. In doing my multiplication, you'll notice I'll have a 3 by 3 as a result, and I can't combine these two because I don't have the same dimension. So now we're going to talk about multiplying two vectors, and in order to multiply two matrices, the number of columns in the first matrix must equal the number of rows in the second matrix, and the product of the two will have dimensions equivalent to the number of rows in the first and the number of columns in the second. So you'll see here, columns first, rows second must match. The answer is rows first, columns second. And multiplication is not commutative within matrices. And you can see this because if I were to switch the order of these two matrices above, it doesn't satisfy the condition given in the previous statement. So now if I want to multiply two matrices, it's kind of similar to doing a dot product on all rows and columns. You'll see over here, I've shown that in this case we have a 3 by 2 multiplied by a 2 by 2, and we get a 3 by 2 as an answer. So these are the elements I'm going to be looking for. If I want to find my first row, first column, this element marker 1, 1 tells me what row to multiply by what column and do a dot product for. So once again, I'm going to get my first row, first column element. And in order to do that, I'm going to do a dot product on the first row and the first column. So a dot product says multiply the corresponding two first parts, so that's 5 and 3, and then add that to 2 times negative 2. Then if I want my second row, first column, I do a dot product on the second row, first column. So I have 0 times 3 plus negative 4 times negative 2. I want my third row, first column, dot product, 1 times 3 plus 6 times negative 2. Now let's move on to our first row, second column element, and I'm going to dot my first row, second column. So in this case I have 5 times 7 plus 2 times 0. Then I want second row, second column. So 0 times 7 plus negative 4 times 0. And then finally, third row, second column, I have third row, second column, 1 times 7 plus 6 times 0. So you'll notice now that I'm just going to find the sum of these products. That's 15 minus 4, which is 11. 0 plus 8, which is 8. 3 minus 12, which is negative 9. 35 plus 0 is 35. 0 and 7. And you'll notice the dimensions of this final solution are exactly what we thought them to be. Let's go ahead and do another one. I notice I have a 2 by 3 multiplied by a 3 by 2. So it's okay to go ahead and multiply those. We get a 2 by 2 as an answer. So I'm going to find these elements. Again, we're going to do a dot product on these now. We're going to go with the first row, first column terms and dot those. So here's the first row, first column. So I have 5 times negative 4 plus 3 times negative 3 plus 5 times 3. Then I'll do my second row, first column. Here's my second row and my first column. So 1 times negative 4 plus 5 times negative 3 plus 0 times 3. Next, I'll move to my first row, second column. So here's my first row, second column. We'll dot those. That's 5 times 2 plus 3 times 4 and 5 times negative 5. Moving to my second row, second column, second row, second column. 1 times 2, 5 times 4, and 0 times negative 5. Let's find all these products and add them up. So that's 20, negative 29, and a total of negative 14. 10, 12, makes a total of 22. And negative 25 gives me a negative 3. Negative 4, negative 19. And then 2, 22. And you'll notice what's left is a 2 by 2, which is exactly what I wanted. Next, we're asked to multiply this set of values. However, you'll notice that I have a 2 by 3 multiplied by 2 by 3. In this case, you'll notice the number of columns in the first does not match the number of rows in the second, so it can't multiply. That's it for our basic mathematics on matrices. Do your lesson summary and fill out to my math lab, and we'll get back to you.